Okay, so I just gave one of the biggest secrets about doing well on this test. If you no, I'm just joking. The recording people think, oh, God, oh, geez. Uh-oh, it's gonna be one of those days, guys. Watch. I've been in like meetings all day. Okay, so page 2. Geez. Okay, I got issues here, guys. I got to clean this up. You know, I set the Keurig thing on 10 instead of 8 ounces, and it's like a disaster. My cup's really full here. Okay. That's just practice for you in case on your test that happens. I'm just showing you how to be calm. And okay. So anyway, what I would do, let me see how this works. I got to do part B anyway. I mean, if you got to do part B anyway, I'm just seeing if that could help me, because I could see there's a lot of numbers in that cloud from here, you know. 32 is like 2 to the, so I'm going to do part B first. If it was me. Okay. To me, it'd be like kind of a no-brainer to do that, which, so, because I said to do it with the quadratic formula, it's like, it's got to be done anyway. Might as well just, maybe that can help me in some way, you know. If it can't, I got to do it anyway. So, okay, so, okay, plus or minus b squared minus 4ac. See, if it says factor over the integers, if this is not a perfect square, it can't be done. Like teacher made a mistake, you know. So, because it would be the square root that doesn't go away, which means it has conjugate irrational roots. You can't have irrational roots over the integers. Integers don't have square roots of 3s and 5s and 108s. And so, I mean, this is called the discriminant, that symbol. Let me just get that calculation right now. So negative 100 squared minus 4. Okay, so this is 10000 minus my phone. Well, no, my phone's working in that sense. Where's my phone at? Oh man, this is like Jerry Lewis Day. Can someone tell me like what this equals, this whole thing? What is, let's see, let me do it by hand.
8,064.
Oh, this right here is 8,064?
Yes.
Oh, okay. And that looks like it. I finally found my phone, by the way. What's that equal?
1936.
So hopefully that's a perfect square. Like,
Yes, 44.
okay, 44. See, that tells you right there. Okay, let me ask the class this. Well, no, it okay.
No.
It doesn't. It's not 44.
I mean, it's
404.
I did it in a different way.
It
Yes.
should be 44.
Yeah, it should be 44.
Oh, okay, good. Okay, so let me ask you this. Okay, I said this is factorable over integers. Does that mean I'm just kind of quizzing you. It is factorable over the integers. Does that mean the roots are integers? Let me ask you that question.
Yes.
Yes.
Incorrect. Which don't feel bad. It's just why I'm asking this. It could be that the root is like 3/4, you know, and negative 6/8 or 6. It could have a rational root, which means like this is a factor. So the root you get from the quadratic formula might be a rational number. It just means you could adjust it and make it factorable over the integers. So it was a trick question. I said, does this mean the roots are integers? No, but if the roots are rational, you can always adjust it and make it. I mean, see, this root is rational, but the factoring has just integers. It still has the root 3/4. But I said, what I said was, maybe I said it wrong. I said if this is a perfect square, does that mean the roots are integers? And the answer is no. The roots could be rational numbers, fractions, but it's still, you could factor it. It'll have this factoring. Like if you said factorable over the rationals, this could be the factor. It's going to be a mess with a lot of fractions. Does anyone understand what I was talking about just now?
Yes.
Okay. So kind of trying to get some conceptual issues down today. So let me see if this helps. It's getting dark around here. Okay. So this means x equals opposite of 100, negative 100, plus or minus 44 over 2 times 63. So this is 100 plus or minus 44 over. Okay. Don't try this at home, but well, try it at home. It's okay. But since 2 goes into both of these, I'm going to do that. You can, as long as it goes into both, it just makes the math a little easier. Oh, geez. Man, I really just, my performance goes in the toilet when I drink. I've had too much coffee today, so forgive me. Which is why I'm trying to teach you, don't drink too much coffee before the exam. Okay, so we got this going on. So this leads to 2 situations, 50 plus 22 over 63, 50 minus 22, which gives us a nice 72 over 63 and a 28, which you want to reduce. 9 times 8, 9 times 8, 9 times 7 gives us 8/7. I've never done this problem, by the way. This gives us 7 times 4, 7 times 9, giving us the nice 4/9. So like I said, the roots are, the actual roots are they're rational, but the factoring, in other words, you go to this, you go to, this is x minus 8/7 times x minus 4/9 set to 0. I'm gonna actually say set. And we see when we multiply by a 7 and a 9 on each side, we get the answer, which is like 7x minus 8 times 9x minus 4. So that's what I call factoring using the quadratic formula. See, it's a different thing. I mean, if I said solve using the quadratic formula, these are the answers. But if I say, and if I said factor over the, okay, let me ask you this question. If I said, this is very tricky. If I said factor over the rationals, no one's going to get this answer right because I'm just being tricky. If I said factor over the answer, over the rationals, which would be the answer, the left or the right?
Left.
That's why I'm being super tricky, because they're both right. I'm just being, I know this was the obvious answer because they look like fractions, but these are fractions also. How are these fractions? Because it's 8/1, it's 7/1. So if I was to make you to pick this answer, I don't know how I would phrase that question. I would have to say something like factor over the rationals where the denominator is not 1. It would have to be really specific. These have exactly the same roots. They're both factored over the rationals. If I say factor over the integers, it has to be this one because these are not integers, coefficients. So we're kind of like, I'm trying to tie up some loose ends of how exact. Does anyone understand that? Like, does anyone understand why this is factored over the rationals?
No.
It's because over means the coefficients of the polynomial are rationals. Well, 7/1. In other words, basically all integers are rational numbers. See, it's like the integers are a subset of the rationals. And then this becomes like, this is the real numbers. The rationals are a subset of the real numbers. The real numbers are the irrationals, the square roots of sevens, the pies, with the rationals, actually, sorry. But anyway, these are rational numbers. So to make you choose this answer, I have to say factor over the integers. If it's factored over the integers, the roots can be rational, like not integers. It's just, if you multiply this out, it's equal to this. If you multiply this out, it's not equal to that. It's equal to x squared minus these crazy fractions plus this 32 63s. Okay, let me ask this question. If I multiply these out, do you agree they don't look alike? Like this has a leading term x squared. Do you agree they don't look alike?
Yeah, they don't look alike.
If I use the quadratic formula, which would be a mess, I have to tell you, it would be a mess. Would you get the same answers?
Yes.
Yes. Is that Josh? Or
No.
anyway, yes, you would get the exact same answers because you would get these answers. Again, I mean, I could multiply this out. So I'm not scared. It's x squared minus 8/7 x minus 4/9 x plus 32 63rds. I just need to add this. It's no big deal. It's like x, you'll see a lot of the same numbers. Minus 72 63 x minus 28 63 x plus 32 63. It's kind of interesting. Look at this. It's actually very predictable. This is minus 100 over 63x plus 32 63rds. Isn't it understandable why this would have the same roots? Because when you're looking for roots, you're doing the situation of this. So isn't it understandable why this has the same roots as this? How do I change this into this?
You gotta
Canceling the 63.
Well, yeah, like multiplying through by 63. See, when you're setting things to zero, it's the awesome power of setting to zero. It's still zero, and you get so it's pretty understandable why it's the same. But again, the subtlety, was I was saying, is these are both. In other words, back to my original point, this is factored over the rationals. I know, not factored. This is over the rationals. And my original point is this is over the rationals also, because it's this. Those are rational numbers. They're fractions over 1. But I said factor it over the integers, which means you're not allowed to have it like this. So anyway, and my original thing was I'm trying to help myself get these clouds. So let's look into that. I kind of, see that? See how this is showing up right there? Does anyone see that?
Yeah,
That's the key. See, that's the key. This is 3 times 3 times 7, 3, 3, 7. This is 2 times 2 to 8 times 4, 1, 2, 3, 4, 5. But in doing this problem, I'm seeing that, I'm seeing these are the cloud puffs right there. As a matter of fact, to even go even bolder of a move, if I multiply through by 63 on this, I would get this. I'm glad I'm showing you this. This is like, you see how I would get that? That's the actual thing you need for the cloud method. I hope you're seeing this or understanding what I'm doing. Like, I multiplied through by 63. So I already know, like, this is if Landsberger is working, like, I would just go like this. And then I would just figure out, what do I need to do that? Oh, bam. I bet $1 million this equals 72. It's 9 times 8. Bam. It just happened. Anyway, and then I would just do what the teacher, I would just do what they want. It's like, okay, minus 72x minus 28x. And then I would factor by grouping. Okay, 9, pretty obvious to me, 9x, 7x minus 8. I bring this over to here. I see it's minus 4 because it's minus 28 plus 32. Then I factor this out. And I'm done. Anyway, so I'm just giving you my inside tips. Like I would have done this problem, part B first, and I would have seen those magic cloud puffs. And if, oh, okay. So you didn't have to do all this fraction thing, but when you got to this, you would still see them manifest because when you multiply it, you get 63x squared minus 72x minus 28x plus 32. You didn't have to do, I was like doing a whole nother extension of going on tangent here. You could have just got the answer and multiply it out and you'll see the puffs. So
Burger, can you go back to the last page you were just had?
is it this or the other one?
That one right there.
Yeah. So the moral of the story is try part B first. If you're, I mean, those are hard puffs to find because the probability, if you work out the probability, is so many more combinations. So yeah.
Dr. Booker, I had a quick question.
Sure. Yeah.
So on that same page for the cloud, so since you multiply 2, 2, 2, and 7, and then 2, 3, 2, 2, and 3 to get 72 and 28, where does the negative factor in?
The negative comes about because whatever happens, these puffs need to add to this number and it's negative. So you could have said to yourself, I'm looking for two puffs to add to 100, but just they got to both be negative.
Okay.
Yeah.
That sounds good. Thank you.
Yeah. And what's noticed that when you multiply, well, this ends up, it's a positive cloud. It just means the puffs have to add to this. Because this times this, if this times this is negative, they have to have a difference of this. So, but you really don't need to say that. All you need to know is those puffs need to add. If this was plus 100, they'd both be positive. I can almost tell you, well, if this is always positive and negative here, they're always a difference. Yeah, it's pretty cool. I like that. I like showing you that kind of trick. It's instructive, it's like anything that makes you more deep on the knowledge. Math is about solving problems. So to me, it's like, this is a problem. It's like, that's too hard. It's like, use math, use creativity, one of the great problem solvers is called Polya. You've heard probably in some of your math 100. They always say, if you can't solve a problem, find an easier problem to solve. Okay, if I can't find this, do the thing you can do. I know I can do this quadratic formula thing. And so I did that. Maybe you'll jiggle something loose to where you can do the other one. So, okay. I feel like we've totally dominated that. So yeah, moral of the story is I'm gonna just come up with a different one. I'll triple check this stuff. No coffee that morning. Okay. So what's next? I gotta share the screen because I don't have this printed out. Okay, so next, this is a tough problem. It's probably the hardest problem on the test. Okay, so problem 2. Okay, it's degree 4 over Z. It's pretty much the theme of this class, over Z, because, well, sometimes I ask a little tricky. Okay, 2 and 1 minus 2i roots, leading coefficient negative 2. Okay, just to let you know, that's at the very end. You have to deal with that. you know? And then part B is show 1 plus 2i. That's the hardest part, probably the whole thing is a root. Okay. So I'm going to tackle this now. Degree 4. Okay. So degree 4. Okay. So, like, let me ask you this question. How much degree is the 1 minus 2i going to give me?
2.
2,
Exactly. So do you see what you're going to have to do to the 2 term? You're going to have to
square it.
square it. Exactly. Beautiful. So that's a good sign. If you answer that pretty quick, actually. So it's a good sign right there. So let x equal 1 minus 2i. Okay, let's form this quadratic that we're going to need. Okay, all right. Get this mouse out of the way. I'm curious, do you see this actual mouse when I move it?
No.
Oh, okay, that's cool. So I'm going to square this thing. Okay, so this is a dangerous stage right here, is because it's kind of like why we're doing complex. You got to make sure you square this right. Okay, let me ask someone in the class. Let me ask Lena. Lena, what does negative 2i quantity squared equal?
-4.
You have passed that hurdle. Okay. This, I'm kind of over this stuff. I go pretty fast. If you have a question how I did that, just, you could always go like this. Base exit, 1, -1, -1, 1. It's right there. Bam. Okay, then I add this. And remember, we let x equal this, and now we have that this happens. That means it's a root, see? But let me, again, today's kind of like training day, like, or I don't know, like graduation day. If I did the quadratic formula on this, you have 3 seconds to answer. What would be the answer? 1, 2. Like if I did the quadratic formula on this, what would be the answers?
0.
No, like if I actually ran this in the quadratic formula, I'm finding the roots. There's degree 2. What would be the answers? One of them better be this.
1
Okay.
plus 2i.
Yes, that must be the other answer. I'll just say check with Q formula that 1 plus 2i is also a root. Even though I didn't. Okay, I'm in a tangent alert. Watch what happens. This is pretty cool. So I do this. What happens when I square 2i?
Still negative.
See, I got the same thing. It's the same thing as this. It means that would have also generated the same polynomial, the same quadratic. So today's, again, graduation day for test 2. Just kind of tying up the loose ends. Okay, I'm going to do an exclamation point there just to kind of, okay. But, okay, so that's why, and again, in the original problem, that's why I ask you, show 1 plus 2i as a root. I'm kind of driving that point. I'm not asking you to show 1 minus 2i as a root. See, so that's kind of the logic of why I asked that. Now I'm actually saying you should know, though, it should equal 0. You should know it better work because it zeroes out this. It'll zero out this. We don't care what we multiply by. This is zeroed out. 0 times anything, it's 0. So, okay, degree 4 and 2. So, okay, so want, okay, page 5, want degree 4. Okay, 2 also a root. Okay, what factor then, if 2 is a root, what's the polynomial linear factor?
X minus 2.
X minus 2, like set. well, don't set, but we have like, so times this thing. Okay, and then you just have to relax for a second.
Square it, Professor.
Yeah, because this is degree 3. So is degree 5. Degree 4. I was going to ask a question like, if you want to make it degree 5, just cube it. I would just mess with this one. If you want to make it degree 5 though, okay, let me ask this question. If I want to make it degree 5, without that 2, like without the 2, what else could I do instead of cubing this? If I want to make, like, if that's not there and I say, what if I said make it degree 5 without cubing x minus 2?
Then square the other one, Professor.
Yeah, you square this, it's degree 4 times degree 1. Exactly. But if I'm working fast, if they say degree 7, well, that's next test. We're going to be getting into, you'll be experts at the Pascal's triangle. On the next test, I could tell you degree 15, and you'll be able to do it pretty fast. You'll be able to raise this to the 13th power within a matter of 2 minutes and multiply that. It won't be the hardest thing in the world. Let me tell you that. That's next test. Maybe I won't go that high, but it won't be that difficult for you. It's kind of like last test I mentioned, oh, next test is complex. Well, this is complex. Next test is binomial expansion. Okay, so, okay, and then unfortunately I said I want the whole expanded form, see?
We also need the leading coefficient to be -2.
And I'm even gonna wait to do that right now, just to make the math. It's a great point, but I'm gonna do that at the very end, just to make the math a little easier, because I'm about to do, first I'm gonna square this, so.
X
Because-
squared minus 4x plus 4.
Yes, exactly. Wow. So this is basically x squared minus 4x plus 4 times this. And so I don't want all those 2's running around when I don't have to. If I get the answer this, I'll multiply it through by -2. And to me, it's just that much easier. It doesn't really matter which is like on top or bottom with base x. That's what's kind of interesting. It's kind of the easiest thing to, so here I'm careful, I put parentheses because that's 1 digit of base x. Shift. I get a little sloppy, I don't put the parentheses around those. 8, if you mess up that negative times negative, the whole problem's, well, ruined in a sense. I mean, it's gonna, so you have to be, this is where kind of I slow down. Go slow, Lance. Slow down. I know I got the problem under control here. Why waste it, mess it up by going too fast? Okay. So this is what I'm getting. Remember, you're adding, you're not subtracting or anything. So we got a 17 parentheses, -6, 1. Better add to 4. 1, 2, 3, 4. Notice I don't go 1 here. That's degree 0. 1, 2, 3, 4. And then I'm going to get kind of sloppy right now. It's -2, right? Oh, yes.
Yes, Professor.
Sorry. I'm going to do this right now. I'm actually going to go, so what did I call this thing? P of x? Or I didn't call it anything? Okay, so let
It's P of x.
P of x equal, I'm going to do this right now. -2, 1, 2, 3, 4, x to the 4th minus 34 x cubed plus 56 x squared minus 40. And I start breaking out stuff like this. Did anyone else get that?
Professor, you are missing a 12.
Yes, okay.
After the -2x squared, it has to be 12x cubed.
Yeah, I forgot the, okay, yes. This is the x term. This is the squared term. This is the, okay, positive 12. Okay, this is all messed up. Okay. Okay, this is equals, okay, I'll rewrite it. So I'm getting negative 2 x to the 4th plus 12 x cubed minus 34 1 2 x squared, okay, plus 56x. Okay, is it correct now?
Yes,
Yes.
Professor.
Okay. All right. See, if I was a student doing these tests, you'd have so much time. I'd probably be like graphing these. I'd at least make sure that root hit 2. And I'd make sure, I guarantee you, if you graph this, it only goes through 2. It doesn't go through, does it say to graph it? Do I have to graph it? Does it say I have to graph this or no?
No,
Okay.
no.
So now the hard part is, this is the hard part. Hardest problem on the test is to show that 1 plus 2i is a root. Just, it's the hardest, at least you know what the hardest part is. Okay, so, okay. So part B continued, P of 1 plus 2i. I'm actually kind of proud of you. Did anyone actually do this?
Yes.
Okay, let me show you what I would do if it was me. If it was me, I would say,
Start with the square and then go.
I would probably go like this. This is just me working stuff. I would go back to this part. It's kind of like just saying all I did is factor out. It's just what I would do. I'm just showing you what I would do. You can do whatever. I just don't want all those negative 2's flying around. So I would probably go like I put a bracket there and I'd go like, I hope this isn't confusing you. I'm just showing you what I would do. Like minus 6. Does anyone understand what I'm doing? Like,
Yeah, you just factored everything out.
yeah, I just took that negative 2 out of there just to, I'm working with the expanded form. I'm not doing anything. Just kind of trying to work. Okay, minus 28. I'm just evaluating what this equals. I just pulled that. I mean, the thing said to do the negative 2, I did it. This is the true expanded form. I'm just pulling it back out again. So let me make sure I did that right. I'm kind of looking more at these coefficients. 1, negative 617, negative 1, negative 617, negative 2820. So if I get 0 for all this, negative 2 times 0 is 0. So now what I'm going to do, this is the painful part. I'm going to actually, I got to expand these. So what do I do? Well, what the nice thing is, I got to do these and these and these. So if I just start, I would just start with this, because every answer builds up to the next one. So it's equal to 1 plus 2i plus 2i minus 4. It's equal to negative 3 plus 4i. So I'm going really fast today. So if you need, if you're getting this stuff, then you did it right. It's just different. If you don't know what's going on, if you're totally lost, you got to tell me. I got to go slower. So don't feel bad. You can even private message me or something. Everyone's good with that one?
Yes, Professor.
Then I just go like this. It's just 1 plus 2i times that one. Because that's the squared one times another one. So it's, I'm just foiling fast. Negative 3 minus 6i plus 4i. Foil it however you want, but the key part is this. It's minus 8i squared. So that's equal to negative 11 minus 2i. Okay. If you got it a different way, as long as you're getting the right answer, which sounds weird, but to say that, but it just means you did it right. You can't do it a wrong way and get that answer. Like, Okay, so the last one, 1 plus 2i to the fourth, it's just 1 plus 2i times this one. Foil it out, -11, -22i, minus 2i. Okay, we have -4i squared. That is +4. -11 plus 4 is -7 minus 24i. And so then it's not too bad. You got to add parentheses, but okay, back to the problem. Ready to do this thing. This is -7 minus 24i minus 6 times. You just got to add your own notation. That's what a lot of students have trouble with when they have to add their own stuff. -11 minus 2i. I use brackets instead of, I don't know, you could use parentheses. Plus 17 times the squared one. It's not too bad. I like this though, just because you're really having to know complex arithmetic.
Minus 28.
Oh, okay. Sorry about that. Having like a phone disaster today. Okay. Okay. I can't get my phone off. Sorry. Try to turn it off here. I got this new phone and it's like my notifications are all. Okay, this is, okay, I messed up. It is minus 20. Oh, no, you're just saying the next one. Okay, let me, yeah, you're just saying the next one. Minus 28 times 1 plus 2i plus 20. So then what I have to do is I have to internally bounce all this around. So distribute. This didn't distribute anything. Plus 66 plus 12i minus 51 plus 68i, I'm getting minus 28 minus 56i plus 20. So now I'm going to just stick all the numbers together. Minus 7 equals, by the way. Okay, minus 7. So let me circle all the numbers. Let me use green. These are the numbers. Okay, so that is, I'll put parentheses here. Plus 66 minus 51 minus 28 plus 20. You can never do wrong by just saying plus and just write the numbers. Minus 24i. Let me do those in red. Just to try not to make mistakes. So this is like the green kind of stuff. It's the red stuff. Okay. I'm just collecting the like terms. You got to realize this minus, it's not going like minus this. There's no parenthesis. It's not multiplying it. It's just with that term. So I can just move it to right there. There's nothing, there's no parentheses inside here. So there's, I already distributed everything in. A lot of students have trouble with that. They think it's like, oh, this is minus a minus. It's like, no, this is like plus negative 24i. So this is why I'm able to do this. Okay, I'm just putting all the like ones together. I almost couldn't read that. Got to be careful. Okay.
68i.
Yeah, let me make sure that's 68i. Is that, doesn't sound right. 4 times 7 is 28. It's plus 68i, right? Okay. Minus 56i. If I was a student, I'd just go with it and see if I get 0. If I didn't, then I go back and panic. Okay, let's see here. It's -2 times, just got to boil it. Let's get all the positives together. It's like 86. And this is -57, -57, -28. It's 86. Okay, it's good enough for me right there. Plus.
Professor, wasn't it 51 plus 7, 58, negative 58.
I don't see, I see a negative 28.
No, because you got on the bottom where you're adding the negatives on the green part. It's negative 51 plus negative 7. It would be negative 58.
Okay, yeah, which makes, thank goodness you said that. 8 and 8 is 6, right? Right here is wrong. Good eye. Yeah, it's weird. I had it wrong and I actually added it to the right answer because I'm okay. So I'm going like a mile a minute here. I wouldn't go this. And then this one is, I'm just kind of making it just a little simpler so I can, so the negatives, this is negative 80, 56 and 24 is negative 80i. And this is clearly 80i, 7 and so I'm just demonstrating. This is like, I'm just showing you what, if I do it, then it's accept, which is negative 2 times 0, which is 0. Check, done. I mean, that's to me how I would have done it. I did the negative 2 at the end. So just to make the arithmetic so I could eyeball it better. Okay, any questions on that one? I'll
Hold on,
scan.
Bruce, go back real quick.
Yeah. I'll scan this like immediately after class because my scanner's fast here. That's one of the
So
reasons.
the 86s, are those right or was that incorrect? Down at the bottom.
Yeah, what she was pointing out was I wrote minus 56.
Oh, okay.
The minus this and this is minus 58. I wrote minus 56 and the minus. Then what did I do? Minus 28. It's minus 28. That was wrong too. Okay. I was doing like a little shorthand and she was just saying, I said something else. And so, I don't know. So I think the moral of that story is just build up the factors or build up the multiplications so that you just are ready to lay them in. I could just see students messing up by like,
Quick question.
okay, but make sure you FOIL those in correctly. If you make one mistake on the sign, you can see what a disaster it'll be. You won't get 0. Let me tell you this before I answer your question. If you're not getting 0 here, you're probably making a mistake, like bringing this stuff in, and you have probably the wrong signs here. So what was your question?
So if I did a different equation, as long as it works out, I'm fine.
That's the beauty of math. It means you had to do everything right. It means everything was right. You just did it a different way. I mean, it'd be really hard to get 0 and make a mistake, and because you would have to make two mistakes at least to get 0, or you would have had to just write 0. And so yeah, it's too complicated to actually have not done it right if you got 0. So I'm not gonna say there's infinite ways to do this, but there's definitely billions of ways to, as far as probability, like, so, okay. So can I go to the next problem? Oh, I'm burning daylight. I have to go.
Yes.
Okay. Okay, so next problem is that's the big one. Okay. This is okay. We got this. Just factor in rational root theorem, problem 3. T of x is x to the 5th. If somehow I don't finish, I'll finish and I'll stay here and finish it and post it. I'll actually stay here and do it, but if you have to leave, I'll post it. Okay, so I mean, if you don't have to leave, I'm gonna just keep working. Okay, so okay, I'm not gonna write anything. I'm gonna just do this thing. So it's a big number. See, RRT, possible rational roots plus or minus 1, plus or minus 18, plus or minus 9, plus or minus 2, plus or minus 3, plus or minus 6. Those are all divisors of 18. Here it's all over 1, so I don't really care. I'm not even going to write it. So I will say, I mean, when I say, oh, this is very much like the test, I might give you one where there's like a 2 here and you have like It could be that 1/2 is a root. That's what I mean by like, don't go. There's past problems I've done like that, so.
Oh, so if there's a leading coefficient burger, then you have to put those
Plus,
like,
yeah,
over,
if that was a 2, there could be redundancy, like 18/2 is 9, so the only, as a matter of fact, the only cases if that was a 2, that'd be additional is like 3/2s, 9/2s, and 1/2s. Because 18s and 6s produce the 9s and the 3s.
okay.
I gotta focus on this one. I'll try T of 1. 1 plus 6 plus 2 minus 27 plus 18. Okay, 19. Yes, equals 0. Do you agree with that?
Agree.
Yes.
Okay. So x minus 1 divides T of x. Let's do that.
Professor, quick
Yeah.
question. You can have the T of -2 too.
Oh, yeah. I'm gonna, the way I did that one, but I'm gonna probably discover though that the other ones. So you just went with that one first, yeah. Is that what you're saying?
Yeah, what I did was I did both and then I connected both like you did it on the
Yeah, you could totally
last
do
day.
that. You could totally do that. I'm gonna do this pretty fast. 6 plus 1 is 7. I'm not gonna.
Be careful. There's no x to the 4th, so there should be 0.
Okay, let's see here.
Yeah,
It's
you
106.
it should be 106.
Oh yeah, see, I was just testing,
You missed a 0.
which was totally on purpose to see if you guys catch that. And it's I have a thing about that. Like, what is my problem with that? Yeah, there's no x to the 4th here. Like danger. No x to the 4th term. Wow. Definitely don't go too fast. So this is that 0 minus 1 is 1. I'm bringing down a 6. Okay, so it's like twice in 1. So I do a 1 again. 1 negative 1. I'm going pretty fast. 6 plus 1 is 7. Bring down a 2. You know, if I was on a test going, if I don't get 0, I know I messed up. If I get 0, I know it's perfect. So I'm going 7. I get 7, negative 7. 2 minus the negative 7 is 9. Bring down the negative 27. I do a 9. I get 9, negative 9. I'm not doing my little plus minus thing. I'm just doing my negative 27 plus 9 is negative 18. Bring down that 18. So I know I did. See, I'm confident I did everything right because I do a negative 18 and I get negative 18. So that just tells me, okay, I was fast, but I'm good. So slow down a little bit. So now I know T of x equals x minus 1 times, let's be careful, Lance, 1, 2, 3, 4, which makes sense. It was degree 5, x cubed. Now, if it was me on a test, I would just briefly in my head do the 1 again. 1 plus 1's 2, plus 7's 9, plus 9 is 18. See, 1's a double root. So I'm gonna just, T of 1 is still 0. Like it's, in other words, it's not T of 1. I mean, T of 1, well, T of 1 is 0 times 0 again. So I'm gonna just, to me, the base x is fairly easy with this x minus 1. I know Shalika did, she did multiple ones at first, multiplied these things together and then divided and probably made short business of it. But this is just the route I'm going. Let me make sure, triple check. 1, 2, 3. 1, 2, 3. Now I know, like, so 1, negative 1. 1 plus 1. I'm going very fast. Sorry. I do a 2. 2, negative 2. 7 minus negative 2 is 9. 9. I do a 9. 9, negative 9. Cross out. I get an 18, negative 18. So I have an 18 on there. 18, negative 18. So I know I did everything right. So you know, if you're getting this right, just, I think the moral of today, every lesson kind of comes up with its own moral. The moral of today's lesson is, if you're getting it right, you're just doing it different, but you understand what's going on.
Professor,
Yeah.
how did you know T of 1 equals 0 times 0, or you just put
I
that?
did it I just did it in my head. I said, I was just going, I guess said 1 + 1 + 7 is 9. 9 + 9 is 18 minus 18. I just did that really fast.
Oh, I see. I didn't get that. Thank you.
Yeah, no, I'm just going a mile a minute. Should have wrote that. I just said before I go on to trying the original one, I just said before I like go through this one again, I'm gonna try like, let me tell you this. I will never work with this one again. If I was doing rational root theorem with these other numbers, I would just work on this one. Because if it's not 1, it's not going to work for this piece. If it works for the whole thing, it's got to be working in this one. If there
Makes
are other numbers. So yeah. I could try -1 just in my head. -1 is 1 minus 1 is 0. 7 minus 9 is -2. I already see -1 doesn't work. I know that's fast. -1 even is 1 minus 1. Okay, that's 0. 7, -1 squared is 1. Minus 9 is -2. So I won't even try that one, -1. Okay, so so far, and now I won't even work with this one anymore. I'll work with this one. See what I mean? I make it easier. So far, T of x is x minus 1 squared times this easier one, 1, 2, 3. It's a very instructive problem. So again, I won't even.
1 and -1 doesn't work on that one.
Exactly, because if it doesn't work here, it won't work here either. And now I'll check 1. Does 1 work? No way. Wait, 9, 11, 1 doesn't work. So I'll quit working with 1. I know this is the end of the road for 1. That's the degree. So -1 doesn't either. So now I'll try 2. 2 is going to get huge. I can kind of tell, like 8 plus 8 is 16. There's no way it's getting plus 18. 2 doesn't work. I'm just not writing everything, but let's try -2. I'm just building up in this piece. I mean, why do it with this thing? I know -2 doesn't work for this. You can see -2, that's -3 squared. So -2, so now I'll slow down a bit, plus 2 times, plus I heard that it works. So this is like, I'm not gonna call it T of -2. I'm just working with this piece. So this is -8 plus 8, that's good, minus 18. Whoa. I thought this one worked. What am I doing wrong?
It's supposed to be plus.
Something's
It's
wrong.
supposed to be plus because the negative times.
Yeah, it's plus. Sorry. I was reading that. It's plus 18. So yeah, this is plus 18. See how things backfire if you're not doing everything right. So it's plus. Okay, so I see, oh, this is -18
Right.
plus 18, which equals 0. So anyway, so -2 works. So x plus 2 divides this. See, once I do this, I'm done because it's degree 2. I can factor, it's going to be easy quadratic. So I do this one. Let me make sure I'm not messing this up again. I can't afford this. Okay, so I got a 1, 1, 2. Oh, you got to be careful when it's like this because that's 0. I drop a 9, but I got to earn bringing down that second one. It's got to be too wide. So you got to put that placeholder to bring it down so you can divide. And of course, the factor theorem never fails. When I subtract that, it's gone. So I'm at this point now, kind of got the answer. T of x equals x minus 1 squared times x plus 2 times x squared plus 9, which I know. Do you kind of know this will never work? Nothing will work in this. It's complex roots. The roots to this are negative. Okay, wait a minute. So it doesn't factor any more down. Did I make a mistake? Let me see what the problem asked. I just hope I asked an adequate problem. Factor over z, that is factored over z. It's I can't factor it anymore. So that's the end. Did anyone else get that answer?
So we have to go until we can't factor it anymore.
Yeah, that's
Okay.
yeah, you cannot factor that anymore. It didn't say factor to linear terms. It just said factor over z. But did anyone else get that, just to make sure?
I got that.
Yeah, good, okay. In other words, they'll often say this is CNF, cannot be factored over z, over z. This factors over c. This actually factors as x minus 3i, x plus 3i. I mean, maybe I'll say, maybe it like, okay, extra credit question. Factor t of x over c. If I said that, the answer is this. That would be the answer for the extra credit. You're allowed to use complex numbers over c. So this is just an extension. Okay, so next, I'm gonna just graph this without using Desmos. Okay, the intercept, I'm gonna just do a rough graph. The y-intercept is 18. It had root at 1, a root at 1, and a root at -2. Okay, let me look at this. This is a double root. This is a linear root. This is just, okay, it's got the quality, its degree, its overall degree is 5. So it starts here, kind of finishes up here. And it just kind of goes something like this, like. But because of this thing, can anyone tell me, is there like a weird bump somewhere? Did anyone do Desmos and see like a little bump? This is a rough qualitative graph, but I don't have Desmos up and running. Let me see here. I'm going to graph this in Desmos just to show you. I think, I mean, I do want you to, if you can, I mean, if I say it, graph in Desmos, try to show that bump. Like, I'm going to graph this really quick. I'll show you what I mean, because it's okay. Let me just graph it and I'll show you. Times x plus 2. It's easier to graph in Desmos if you just type in the factoring form, in my opinion. Squared plus 9.
There's a bump on 40.
Okay, so let me see here. Yeah, so just to show you, there is no, it's too skinny to really see the bump, so it's okay. Well, I mean, to prove my point, it why isn't it? Okay, let's see here. Do you see the Desmos?
No.
Really? You don't?
No, no.
Okay, now you do, right?
Yes.
So you see, because it's so skinny, it basically has the qualitative features. Yeah, it does have, see, it's kind of like this more. So I'll probably tell you on the test explicitly use Desmos, like, so to show you what I mean, like, do you see my thing now?
Yes.
Yeah, see, I graphed like this, but the actual graph, it has this kind of weird little hump here. It's qualitatively the same, but you know, it's got a little hump there. That's kind of due to the that is due to this interaction of these complex roots, making it like that. It's still got the feature that started here, it went through that, and it had this multiplicity too.
Professor, may you show us how you graphed it on Desmos so we can see?
Yeah, I just put the factored form into it. Oh, geez, Louise, what is going on with this? Okay. Do you see what I entered there?
Just the roots, all the roots.
Yes, because I typed it x minus 3i and it didn't graph. So I see what I did wrong.
Yeah, that's a good point. You can't, everything in Desmos is in real numbers. It shows the graph, but you can't type complex. So yeah, that's a good point to know. Yeah. Like this is graphing complex. It's kind of entering the like 4-dimensional realm. So you can graph x squared plus 9 as complex roots, but you're not seeing those roots. You're seeing the effect of them if you sliced out 2 dimensions of the real graph. What we're witnessing is almost a 2-dimensional slice of the real complex graph. So, okay. So I gotta get rolling here. Okay. Ah, really lost some. So what's the next problem? 10, page 10. The next problem is, okay. Okay, this one, 4. Okay, it's basically a graph thing and sketch.
I think it's supposed to be minus 5x. That's what you put on the new modified one.
Oh, don't tell me this is the old one. Let me see
The
this.
new ones, it says plus 5x.
Yeah, this is the new one.
Oh, okay then.
I'll be able to tell real quick when I try to use the rational root theorem. And on the bad one, nothing should work. It actually doesn't have any real real roots. They're all complex. So I'll just call this P of X. So okay, RRT, possible rational roots, plus or minus 1, plus or minus 2. Sure you understand why. So already I'm kind of thinking this thing is kind of like something of this form. It's like concave down and it's even. The one that I gave you that was messed up, it was like this. It had no real roots. That's why nothing from the rational root theorem worked. So let's try P of 1. It's -1 plus 5 minus 9 plus 7 minus 2. When you put 1 in, it's just the coefficients. So it's -10 minus 12 plus 12, 0. Check. Okay. Let me try like Shalika's saying, let's try -1, see if that works. That's -1 minus 5 minus 9. No way. It's everything's, that's, I don't even compute that. So let's just deal with this right now, make the problem easier. So x minus 1 divides P of X. Okay. Let's do that. Be careful that I've been messing up on that. It's descending. That's good. We call that just descending. Okay, we've got a -1 here. Be careful. Because I need, oh, no. Yeah, I need this to be -1 right there. This times this is positive. So this is 5 minus 1's 4. I'll do a 4. -1, -9, +4 is -5, 7. Okay. Oh, whoa, did it so fast that it's -5, +5, 2, -2. Okay, I'm doing everything correct. 2, 2, -2, 0. Okay. Things going fine. So that means I'll scan this. P of X is X minus 1 times. Okay, you're not gonna like this next move. I don't think you're gonna like this one bit. I'm just showing you how I would work. If it was me, what I would do. Can anyone predict what I'd do?
Try the -1.
Yeah, I would take this negative here and I'd go like this. And I would say x squared, x cubed minus 4x squared plus 5x. I'd just start working with that from now on. 1, 2, 3. And I would take the opposites and just pull this to the front. And I would only work with this. I could have done that from the very start. If I had to do it all over again, I would have probably pulled the -1 out and just kept it out there and worked with this positive or negatives through there. But I didn't. And it's like, I mean, the heat of battle, it's like, say the test is ending soon. I gotta get rolling. I already know 1 doesn't work in this. I already know, no, 1 could 1. Did I try 1? 1 could work again. Try 1 again. I know if -1 doesn't work in the original, it won't work in any piece. But if something works, it could work again. So I'm going to do that. That is 6 minus 6. Yes. It did work again. I got to do a 1, -1 in this piece. Okay. -4 plus 1, 3. 3. 5 minus 3, 2. Going really fast because like the test pressure's on. 2, -2. Okay. I'm really getting through this thing. It's negative x minus 1 squared times x squared minus 3x plus 2. Okay, the answer is negative x minus 1 squared. Just do it in your head. It's okay. 2 and 1 minus minus. Done. Did anyone get that?
No, I'm still behind.
Okay, I know. I was going. That's there, but
You're good.
I'm just factoring this really fast. Multiplies to 2. It's kind of like that cloud thinking. I kind of got the cloud thinking. I'm always looking factors that, Anyway, what did I have to do next? I have to draw it. I'm going to sketch it. I'll just sketch it right here. It's concave down. It has a double root at 1. It has single roots at, a double root. Whoa, it's x minus 1 cubed. Did anyone see that? It worked again in there. It worked again. It has a triple root there. And so it's negative, which means it starts down here. It's even degree 4, and finishes down here. Let's get that y-intercept. The original problem was -2. If I stick 0 in, it's -2. It's all I do. That's all I'm kind of asking out of you. Get the y-intercept. It finishes, and it's got a triple root at 1. So that's kind of something like -2.
Professor, can you raise it up a little?
Okay. X minus 1 cubed. What am I concerned about? Factor that right. Okay. -2. I'm at that same stage. I'm always at like, wow. At 2 is right here. So it's kind of like, Yeah, it never goes through any, there are no positive, negative roots. I'm getting something like this, like, kind of like. I'm getting this, which I remember is true. Did anyone get anything like that? It's got a triple root at 1 and a linear root at 2, and it's concave down. I remember doing this. It's true. Can anyone back me up on that? That it looks like that? Look at it, it's doing everything it needs to do. It's concave down. It's going through -2. It kind of does this little cubic thing. Then it comes back down straight through that 2. The roots are right here. Is anyone left in the audience? Yeah, 13.
We're
Anyway.
still here, Professor.
What's that?
I said, we're still here. I graphed it on decimals and it looks slightly different. Maybe I typed it in wrong.
Okay, I'll do it fast.
Are we supposed to type the one where it says P of X minus parentheses X minus 1 or the one in red?
I would type this in basically. If I was on a test, I would type this one in. I'll type it in right now.
Okay, I typed
Oh.
incorrect, so thank you.
Okay, yeah. Do you see Desmos right now?
Yes.
Yeah, it looks like that. I graphed it.
Okay,
It
I'm
looks
gonna
like-
type it right now. X minus 1, close, caret 3. You got to do the arrow button, arrow down, parenthesis, X minus 2, close parenthesis. And you have to zoom in. I'm holding down the mouse pad. You see it's doing it. It's going through -2. It's got that triple root and it comes back down linear, kind of a, if you were to zoom in like really close, it would look kind of like a line going through there.
I got the same, Professor.
Yeah, okay, cool. Okay, that's good. Good stuff then. The last problem, 12, that I just added, is one of those C things. So let me get that going on. Okay. Last problem of the test. Okay, let's do this. So 2 plus I, a root, and find D, find D. It's over Z, over Z. These problems for me are kind of a pleasure to do. Well, they all are, but this is pretty easy if you know what you're doing. Okay, find D. So what I do is, so you all see my paper, right?
Yes, Professor.
Yeah.
Okay, so 2 plus I is a root. So step 1, I guess, let X equal 2 plus I, X minus 2 equals I, X minus 2 squared equals I squared, which is of course X squared minus 4X plus 4 equals -1. Okay, so we just found the trinomial that has that as a root. Okay, let me ask the class again. If I was to do the quadratic formula on this, what would also be a root?
2 minus I.
See how fast you guys are answering that? That's good stuff right there. So, okay. Find D. So what do you think I do? It's this class is about to end. What do I do?
Divide it by the,
By this. Don't divide it by like this or something. Don't divide it by X minus 2 minus I. So
yeah, that's what I,
so the factor theorem is going to solve this problem for you. Okay, don't make the mistake Lance Berger's made twice. Make sure those degrees are descending. Okay. Be kind of careful on this. Okay. See, I'm getting kind of sloppy. As long as I kind of know the spaces are there, you know, it's kind of, okay, okay, I'm taking them 3. It's not that many steps. We're almost done. Like 2, -8, 10. I'm kind of just doing this stuff in my head now. It's negative 14 plus 8, it's negative 6. 40 minus 10 is 30. Almost done with this class here. What do I multiply by now?
Negative
Negative
6.
6.
Yes. 14. Negative 56 plus 30 is negative 26. Bring down that 38. Of course, you know it's a 14. Now it's even at getting ones where it's lucky it's 1 here. If it's not 1, I mean, just think it
I
out.
don't think it's 14. 30 minus 24.
Oh, right. It's 6, huh?
66.
And that was just a routine little spot check I do to see if people are still paying attention. Thank you for you passed that test. Okay. So it's 6, correct?
Correct,
Yes.
Professor.
6, negative 24, 30. Okay, you guys are quick. It's good. You're passing all these little tests I do. Negative 26 plus 24 is negative 2, 8. And we are ready to solve this problem. Bring down the D. I do a negative 2. I get a negative 2. And it's very important. You know you're doing the problem right if you get this to be 8. And then you get this beautiful negative 10. So what does D equal to?
Negative 10.
I don't, yeah, you don't need to do it. Just, you could do D equals negative 10, done. Or you could actually say this. If you do not do that, say D plus 10 equals 0, because this has got a 0 out. D minus a minus 10 equals 0. As you see, you solve for this. I'm just saying there's 2 ways that, but I don't mind on the test if you just jump to, like, this should be identical. Okay, I am canceling the rest of class. So you guys are getting off the hook easy today. I'm going to cancel it. So any questions on that? Or it usually gets them roaring in the aisles when it's like live, but okay, is anyone left? Yeah, 12. Okay.
Yeah.
So I'll post this. I know this was crazy whirlwind, but I think just study the notes and I'll post the video. And I know I'm making some mistakes, but I've been told they're helping people actually to see these kind of things to be careful for. So you saw like 2 or 3 times now, I got to be careful about counting that degree off right. Placeholders are key for base X. And if you don't get to stuff zeroing out, that means you maybe made that mistake. So, and today you saw me doing this stuff quick without doing the minus, negative, and adding. I just was doing it in my head. 8 minus a negative 6 is 8 plus 6, or no, 14, negative 14 plus 8. I don't mind if you do that. So, all right, good
Mr. Berger?
class. Yes, yes.
Why'd you put circle 12 in your work?
Oh, that's page 12. Sorry.
Okay, thank you.
Yeah, sorry. That's great.
Professor, you will upload this video tonight, right?
I'm uploading it within, because I'm at school, so everything's faster. I'm on a network connection and it'll be uploaded before you eat your dinner, or I mean, before you probably, I don't know, the next 10 to 15 minutes. So,
Thank you.
okay. So Wednesday, we'll have your test coming up at 4:45. Just relax and have fun. I feel a good vibe and feel like you're prepared. So
Hey, Burger, real quick, would you mind doing a rational root theorem with like a leading coefficient? Because I'm kind of lost on that still.
okay, I'll make one up, like 2x minus 1 times, gosh, let me get a little 3x plus 1. Are you okay if it's kind of an easy one? Well,
Yeah, that's fine. I just to know how to do it.
do that. Like, see, this has roots 1/2 and negative 1/3. So if I was making a test, I kind of start with stuff like that. First, I got to multiply it out. So it's like 1, 3. Then I'll do a 2, negative 1. So what's good about base X, I can make problems pretty fast. Okay, 2. So if I gave you something like m of x equals 6x cubed plus 5x squared minus 2x minus 1. Look at this thing. This thing has possible rational roots. It's almost like the reverse. Everything's plus or minus 1 on the top, but you got a 6 plus or minus 2 plus or minus 3, all the possible divisors of 6.
Okay.
And you always got plus or minus 1 because 1 divides 6. So if I was doing this one, I would still kind of go to my, well, you would see 1 doesn't work, 11 minus 3. But if you saw m of negative 1, you're going to see it works. This one's kind of easy because you'd be able to get to a quadratic fast. But so if it was bigger though, all I can tell you is like m of 1/2, it's not too bad. I mean, it's like 6 times 1/2. It gets into things like this, you know. You just got to be prepared. That's like 6/8 plus 5/4 minus 1 minus 1. I mean, you get a common denominator, you have to just do stuff. It's kind of a pain. 6/8 plus 10/8 minus 2. 8 is 16/8. And so you can see it zeroes out. But so that would, if I saw that happen, if I saw x minus 1/2 is a factor, I would not work with that in my base x. I would work with 2x minus 1 in base x. Use this for base x. Like if I see 1/2 works, I would divide that original thing, this, I would divide it by this. Let me just show you that it works. Like for example, okay, so in base x, 6, 5, -2, -1. So I saw 1/2 was a rational root. I would use this 2, -1, and you see 3, 6, -3, 5 plus 3 is 8, 4, 8, -4, -2 plus 4 is 2. You see it works perfectly.
Yeah.
And then you're getting this 2x minus 1. In this case, it wasn't too bad because, wow. Yeah, that just happened. That factors because 3x, it's got to be this, and it's got to have ones. And it's, but if this is cubic still, you just got to try the 1/2 again, or I don't know. But
Sounds good. No, I just to like refresh the mind.
yeah, the theory doesn't really stop. It keeps, it'll work. But I think the key of that is if you get this to work, do not work with this, work with that.
Okay.
So, okay, all right.
Professor,
Yes.
on that same question, how did you get the 1/6 and the 1/2?
It is because problem I came up with, what happened?
Talking about the plus or minus, Burger. Like, how did you get the plus or minus 1/6 plus or minus?
Right. Trying to find the original paper. What
The
happened?
divisor, I think, that's what,
It's the rational root theorem, but I just can't find the original problem. Like, did I, God, like vanished in thin air. Did I put it, shuffle it under?
I think it's a paper that's right
Oh.
there,
It's,
right there.
oh, it's right here, yes. It's because the rational root theorem, the rational roots are the divisors of this divided by the divisors of this. I always do the plus and minuses on top. The only divisors of one integers is ones. That's why I said it's the reverse of like the usually this is 1. And we have all the divisors of some weird other number over 1. Now it's all just ones on top, plus or minus, divided by the potential integer divisors of 6. 6 divides 6, 2 divides 6, 3 divides 6, and 1 divides 6.
Okay.
I just don't put the and so
That makes sense, Professor.
yeah, but the only one that came into play was 1/2. And look at, they're all there. 1/2 is a root. -1/3 was -1/3 was 1. I made it like that. -1. It doesn't say they're all going to work. It just says the only rational roots are these possibilities. So
Okay.
I don't think I'll go too bananas on that stuff, but I don't know. Just if I do it to, I'll try to limit it to maybe only one interaction or.
Sounds
But-
good. Thank you, Burger.
Yeah. Okay. All right. Good class.
Thank you, Professor.
Yeah. Actually,
Yeah.
next time I see you will be after the break. So have a good break. And I'm going to grade these things. I don't want to like grade during my whole break. So I plan on getting this stuff graded quick. So, okay.
Thank you.
Yeah. Thank you.